Hey there, this is tonight's notes 5-7, which is titled the motor unit. We've taken a look at how an axon affects one single muscle fiber. So now we're going to take a look at what happens when several axons jump in and affect several muscle fibers. So the contraction of a skeletal muscle is the result of the activity of groups of muscle cells called motor units. The size and number of motor units being stimulated is an important factor in determining the strength of a contraction. So this is just kind of like an intro into the section. So what is a motor unit? A motor unit is all the muscle fibers that the motor neuron supplies. So each muscle is going to have at least one motor nerve containing axons and hundreds of motor neurons. So here's a little picture over here showing this major axon coming down, and see how it branches into several different little smaller sections, and they each end at a neuromuscular junction. So each of these little sticky pad looking things here is a neuromuscular junction. Each one of these is one cell, and then all the little things inside, those are myofibrils. And so each individual cell gets one of these. Now this picture doesn't do it very good because it's showing that this one cell has several of them, but it's actually each one cell gets one of these. So so the motor unit then is the motor neuron and all the muscle cells supplied by that particular neuron. Now your muscle cells, depending on what their job is, will have big ones or small ones. So like your eyeballs, which barely have any muscles that have to move at all, they have very small motor units. So they don't have a whole lot of cells affected by them. But your thigh, because there's lots of muscle there, has very large motor units. The fibers of a motor unit are spread throughout the muscle, not isolated to a small portion. So if I take a cross section of a muscle, a motor unit is not just going to be here's motor unit 1, here's motor unit 2, motor unit 3. Because then if I only stimulate that one, only that chunk of my muscle will contract, and that would be weird. So what happens is the motor neuron comes in and spreads out all throughout the cell. So if I only want my muscle to contract a little bit, well then it'll only contract those cells. But if I have another neuron come in and it's affecting more of these cells, well then when I make both of these contract, more cells will contract. Okay? So the main thing is that they're spread throughout the muscle, not isolated in little packets. Okay, small motor units only have a few muscle cells per motor neuron. So having only a few muscle cells per motor unit allows for very precise, detailed movements. Like your hand. Think about all the fine, detailed drawing and things that you do with your hand. So we have a lot of small motor units affecting our fingers, but yet we can use our hand to grab onto and contract and pull something heavy. It's mostly up here that's happening, but we can have some major contraction going on there. So things like eyes, fingers, anything that has very small, detailed, precise movement would be an example of a small motor unit. So eyes, fingers, eyelids, I can't think of any more. Then we have large motor units, which is having many muscle cells per neuron. So whereas this one here's a neuron may have 3 cells, this neuron's going to maybe have like 20 cells per neuron. And so that allows for greater movement with a bigger force. Example, your thigh muscles have many cells per unit, resulting in large movement. Because if your thighs could only do what your eyelids do, well, walking would be very difficult. And if our eyelids could do what our thigh could do, man, we could rotate our eyes all the way back in our head. So how do I figure out how many muscle cells are going to come into a play? Because with my thigh, maybe I only want 3 of them to contract. Maybe I want all 20 of them to contract. So what happens is my brain is going to tell how many cells are going to contract at a time. So we call that recruitment. So that's my brain recruiting more cells to contract. So when a strong contraction is needed, more motor neurons are stimulated, causing more muscle cells to contract. So if I only stimulate one neuron, just a few are going to contract. If I stimulate a whole bunch of neurons, well then I'm going to get a big contraction out of that. Muscle tone is our muscles are constantly in a state of slight contraction. Just maintaining an upright posture involves your muscles being constantly stimulated, so that way they can make minute little detailed changes to keep you upright. So all your muscles, even when you're asleep a little bit, they all have tone to it, so they give your muscles shape. So a relaxed skeletal muscle is still slightly contracted because there are asynchronous motor unit contractions. So your brain is constantly going zap, 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 to different parts of your body, and that keeps your muscle slightly contracted. Now, I don't know if you've ever seen someone who has a spinal cord injury, or there's no zapping affecting, say, the legs. So someone with a cut nerve to their back, those muscles would lose tension, and they get a flaccid floppy muscle because there's no tension to it whatsoever. So even when your muscle is what you would consider uncontracted and you flop it about, it's still tight. But if you had no brain signals going to that muscle, it would be very loose. So these types of contractions that affect our muscles come in two varieties. We have concentric and eccentric contractions. Concentric contractions is where the muscle shortens and does some sort of work. So if I pick up something heavy, it's doing work. So that's concentric. Eccentric contractions is the muscle lengthens, so it's going beyond the contraction. Trying to think of, it's almost like when you're carrying groceries inside the house. Your arm is straight holding the bag of groceries, and it's contracted a tad because those groceries are heavy, but it's not, you're not doing this with the groceries. And so that's an eccentric contraction. Then we have something called an isometric contraction, which is a type of one of these. This is where tension does not produce shortening or lengthening in the muscles. That's kind of like if you pick up something that's so heavy that you actually can't pick it up, the force involved in trying to pick it up would be called an isometric contraction. I'll talk a little bit more about this on the next one as well. Okay, this is a nice short one. I believe that's it. Yay, we're done. Okay, so just a little tidbit, and then we'll go over the next module in class. Thanks, guys. Bye.